For question number 1, the image below shows kite ABCD whose points B, A, and D lie on circle E. The measure of angle BAD is 66 degrees. Use what you know about properties of kites and angles and circles to determine the following. So what we know is that angle BAD, that's this angle right here, is 66 degrees. We also know that points B, A, and D lie on the circle, and this is our kite. Well, properties of a kite say that two adjacent sides are congruent, but they're not congruent to the other two adjacent sides, which are congruent. We also know that this angle is going to be congruent to this angle because there's one set of congruent angles in a kite, and they are the opposite pair of angles that make up the angles formed by the two non-adjacently congruent sides, if that makes sense. So one of the first things we're asked is to find measure of arc DAB. So we're finding this arc right here. I can see that I have an inscribed angle right here. That's going to give me this angle, which is going to be 66 times 2, which is 132 degrees. So I know arc BD is going to be 132 degrees. That means BAD, or arc DAB, is going to be 360 degrees minus 132 degrees, which is 228 degrees. So that's how we get A. Next, we're going to find BCD. So we're going to find this angle right here. So I want to know, what is the measure of angle BCD? Well, I know that this is an intercepted arc, so this arc, I'll write this, the measure of BAD, arc BAD, so this arc right here, minus this arc, which is minus the measure of arc BD, divided by 2, is going to give me the measure of angle BCD. Well, BAD is 228 degrees. BD is 132 degrees divided by 2. So that's 96 degrees divided by 2, which gives us 48 degrees. So this angle right here is going to be 48 degrees. Finally, we need to find the measure of angle ABC. So this angle right here. Well, what I know, as I said before, is that this angle is congruent to this angle. So the measure of angle ABC is going to equal the measure of angle ADC. We also know this angle, and we know this angle, and it makes a kite. A kite is a quadrilateral where all four angles add up to 360 degrees. So we have 66 degrees plus the measure of angle ABC plus 48 degrees plus the measure of angle ADC is going to equal 360 degrees. 66 plus 48 is 114 degrees, and we know that this angle is equal to this angle. So I can take 2 of those angles, and they're going to add up to 360 degrees. If I subtract 114 on each side, 2 times the measure of angle ABC is going to equal 246 degrees, and then I can divide by 2, and the measure of angle ABC equals 123 degrees. So that's how we get this final answer of 123 degrees. Question number 2 says the image below shows circle F with perpendicular tangent lines at points A and B. Use what you know about tangents and angles and circles to determine the following. So what we know, let's move this up. What we know is that we've got perpendicular tangent lines at points A and B. So we know that these lines are perpendicular. We also know that if we make a radius, our radius is always is always perpendicular to our tangent line. So we know angle FBC will be 90 degrees, but we also know that angle FAC is going to be 90 degrees. So right now we're looking at, obviously this is going to be 90 degrees then, that we either have a rectangle or a square. We also know that this is a radius, which means it is congruent to this side. And if two adjacent sides are congruent, then we know all four sides are congruent, and shape AFBC is going to be a square. All right, next thing, we need to find the measure of angle AFB. Well, we already figured that out. It's 90 degrees. And now we need to figure out the measure of arc ADB. Well, I know this is a central angle of 90 degrees, which means this arc right here is going to be 90 degrees because the central angle and its intercepted arc have the same degrees, which means that the remaining part, ADB, is going to be 360 degrees minus 90 degrees, which equals 270 degrees. So this arc is 270 degrees, and that's question 2. Question number 3 says the image below shows the relationship between circle I and triangle ADG. So that's this triangle right here. Given that measure of angle CHE equals 10 degrees, measure of angle HEF equals 17 degrees, measure of arc FBC equals 230 degrees, and the measure of arc BFE equals 190 degrees. Use what you know about angles and circles to determine the following. So I'm going to move this up. What we were given was that CHE. So I'm going to need to draw that line. CHE. We know this angle is 10 degrees. From that, just to, state it, arc CE is going to be 20 degrees because this is an inscribed angle, so it's twice as much. HEF, measure of angle HEF, is going to be 17 degrees. That's given. So the measure of arc HF is going to be 34 degrees because it's twice as much. Next thing we know is that arc FBC is going to be 230 degrees. So I'm hoping to use colors to help you distinguish between these. And arc BFE is going to be 59 degrees. I'm sorry, not 59 degrees. Sorry. 190 degrees. All right, looking at this, I can see that this whole arc is 230 degrees, and this whole arc is 190. So if this is 190, this arc right here is going to be 360 minus 190, which is 170. Since we know this arc is 20, that's telling me that measure of arc BC is going to be 170 minus 20, which is 150. What this allows me to see then is that I have this arc, which is 230, but let me change my color again. Make it a little darker. This arc, take away this part, which we just found is 150, and this part, which is 34, means that measure of arc BH is 150 plus 34. That gives me 184, and it is 230 minus 184, which is 46 degrees. So BH right here is 46 degrees. So let me just go through that again. This arc is 230 degrees minus 150 minus 34 gives me this last part, which is 46 degrees. All right, if I know, now I know pretty much all of my angles. Just for the sake of it, I think I need this. The measure of arc FE, well, I know every other part. This is 20, this is 150, this is 46, this is 34. So it's really just 360 minus all of that. So 150 plus 20 plus 46 plus 34. And that's going to come out to 110 degrees. So the first thing I need to find is the measure of angle CDE. Well, I see that, let me change my color again. I see that this angle measure is this arc minus this arc. So measure of angle CDE is the measure of arc BF minus the measure of arc CD divided by 2. Well, BF is 46 plus 34. CD is 20 divided by 2. And what we're going to get is 30 degrees. So CDE is 30 degrees. Next, we need to find BAH. Well, I'm going to do the same process. To find BAH, it's going to be, let's go to our intercepted arcs. So we've got a point here and our point here. So it's going to be this arc minus this arc. So the measure of angle BAH is the measure of arc HFC minus the measure of arc BH divided by 2. Well, HFC is 34 degrees plus 110 degrees plus 20 degrees. And we're going to be subtracting BH, which is 46 degrees, divided by 2. And what this should give us is 59 degrees. So the measure of BAH equals 59 degrees. Finally, we have to find the measure of arc the measure of angle FGH. So this angle right here. Hopefully you can see that. Well, what I know is that this is a triangle, and the angles of a triangle add up to 180 degrees. So the measure of angle CDE plus the measure of angle BAH plus the measure of angle FGH is going to add up to 180 degrees. So this is going to be 30 degrees plus 59 degrees plus the measure of angle FGH equals 180. 30 degrees plus 59 degrees is 89 degrees. So the measure of angle FGH is 180 degrees minus 89 degrees, which equals 91 degrees. And that is problem 3. Question 4 says the image below shows circle J with 4 secants creating regular trapezoid ACDF. So that's going to be important. Given the measure of arc EDC is 152 degrees, the measure of arc EGB is 122 degrees, the measure of angle GJH is 55 degrees, and arc GE is congruent to arc HB. Use what you know about angles and circles to determine the following. I'm going to make this a little smaller. All right, let's start with our givens. We're given that EDC is 152 degrees. So the measure of arc EDC is 152 degrees. We know that EGB is 122 degrees. So the measure of arc EGB is 122 degrees. And the measure of angle GJH. So we have to make that GJH. This measure right here is 55 degrees. Well, looking at this, that's a central angle because J is our center. So the measure of GH is also going to be 55 degrees. And then the last given is that arc GE is congruent to arc HB. So what we know is that EGB is 122 degrees, and it's made up of this 55 degrees and 2 congruent arcs. So we know measure of arc EGB is equal to the measure of arc GE plus the measure of arc GH plus the measure of arc HB. Well, EGB is 122 degrees. Measure of arc EG and HB are congruent, so I'll take 2 times the measure of arc EG plus GH, which is 55. Then 122 degrees minus 55 degrees is 67 degrees. So divide both sides by 2, and the measure of arc EG is going to be 33.5 degrees. This means also that the measure of arc HB is also going to be 33.5 degrees. So this is 33.5 degrees, and this is 33.5 degrees. Next, I know that EDC is 152 degrees, so this part, let's say measure of arc EHC, so the measure of arc EHC is going to be 360 degrees minus 152 degrees, and that's going to be 208 degrees. So if this is 208 degrees, measure of arc BC is going to be 208 degrees minus these 3 parts. So minus 33.5 plus 33.5 plus 55. So measure of arc BC is going to give us 86 degrees. Next, I can see that this angle right here, this inscribed angle, is half of 86 degrees. So this arc right here is going to be half of 86, which is 43 degrees. This inscribed angle right here is going to be half of 55 plus 33.5 plus 33.5. So 55 plus 2 times 33.5 divided by 2 is going to give us an an angle measure of 61 degrees. So the measure of angle EDC is going to be 61 degrees plus 43 degrees, which equals 104 degrees. Next, we have to use the fact that we have a regular trapezoid here. A regular trapezoid means that we've got two isosceles sides and two isosceles sides, meaning these are congruent, and one set of parallel lines. We're going to have to use that fact of parallel lines to answer this next part. I'm trying to find the measure of GFE. I know that this is parallel to this, so I could look at this being cut by a transversal and see that by alternate interior angles this is congruent, or by corresponding angles GFE is congruent to this part. Well, we have a straight line, so we have supplementary angles, meaning that this is 180 degrees minus 61 degrees plus 43 degrees. That's what we found up here, which is 104 degrees. So 180 degrees minus 104 degrees, and what we have is 76 degrees. If this angle is 76 degrees, then this angle is also 76 degrees. And measure of angle GFE is going to be 76 degrees. Now that we've found the measure of angle GFE, we can use our intercepted arcs theorem, whatever it is, to look at this arc minus this arc divided by 2. So the measure of angle GFE is going to equal the measure of arc, let's call it HCD, minus the measure of arc GE divided by 2. Well, measure of angle GFE is 76 degrees. The measure of angle HCD is 33.5 plus 86. That's 119.5 degrees, plus the measure of arc DC minus measure of arc GE, which is 33.5 degrees, divided by 2. So 76 times 2, because we're going to bring this over to this side by multiplying both sides by 2, is 152 degrees. 119.5 degrees minus 33.5 degrees is going to be 86 degrees plus the measure of arc DC. So the measure of arc DC is going to equal 152 degrees minus 86 degrees, which is 66 degrees. So this arc right here is going to be 66 degrees. Next, we need to find what arc ED is. We know this arc, this arc, this arc, this arc, and this arc. So really all we have to do to find this arc is 360 minus the sum of 33.5 plus 55 plus 33.5 plus 86 plus 66, which is going to equal 274 degrees. So 360 minus 274 is going to be equal to 86 degrees. So the measure of arc ED is 86 degrees. So finally, we can find the angle BIC because we've got vertical angles here. So the measurement of this arc plus the measurement of this arc divided by 2 will give us the answer. So the measure of our angle BIC is going to be the measure of arc BC plus the measure of arc ED, all divided by 2. Well, measure of arc BC is 86 degrees. The measure of arc ED is 86 degrees, all divided by 2. So 172 degrees divided by 2 is 86 degrees, meaning this angle is 86 degrees. And measure of angle BIC is 86 degrees. Question 5 says the image below shows regular hexagon ABCDEF inscribed in circle G with a radius of 4 units. Use what you know about angles and circles to determine the following. So we need to remember that we have this radius of 4 units and that it is a regular hexagon. Alright. So a regular hexagon means that each side, each part, like AB, BC, CD, DE, EF, FA, are all congruent. So if I make a radius, and I make a radius, I can make these to all these points. Sorry, they're not straight. These are all going to be 4 units long. We first want to find arc BC. The other thing that's special about a regular hexagon or any regular figure is that all of these angles, these central angles right here, are going to be congruent as well. So we can figure out this angle by doing 360 degrees divided by the number of angles, which is 6, and that's going to give us 60 degrees. So each of these central angles is 60 degrees. We also know then, because this side is congruent to this side, that these two angles are congruent. And if this is 60 and these two angles are congruent, this must be that all of these triangles are equilateral triangles. To answer the question about the measure of arc BC, well, it is made by a central angle. Central angles have the same measure as the arcs they intercept, so BC must be 60 degrees as well. Also, if these are equilateral triangles, and this is 4 and this is 4, this length right here must also be 4, which means this is 4, this is 4, this is 4, this is 4, and this is 4. Our perimeter is going to be 6 times 4, which is going to be 24 units. Finally, we need to find the area of trapezoid AB. I'm just going to draw it in here. ABCDEF. So we're looking for the area of this blue trapezoid right here. Well, the area of a trapezoid is 1/2 base 1 plus base 2 times the height. You could also look at it in this particular case as the area of one of these triangles times 3. Well, my base 1 is going to be 4 units long, and my base 2 is going to be 4 plus 4, which is 8 units long, and I need to find the height. So let's first work on finding the height. The height's going to be a height of one of these triangles. And because it's an equilateral triangle, we know that it's going to form a perpendicular angle with the base, but it's also going to bisect the base. So we know that this is going to be 2 units. We know that this is 4 units, so 2 and 4, right triangle, we can use Pythagorean's theorem. So a squared plus b squared equals c squared. My height squared plus 2 squared is going to equal 4 squared. So my height squared plus 4 is equal to 16. My height squared is going to equal 12, and h is going to be the square root of 12. So my height's going to be the square root of 12. So when I put it back in my formula, we have 1/2, 4 plus 8 is 12, times the square root of 12. 1/2 times 12 is 6, so we're going to have 6 root 12, and this rounds to 20.785. Now remember, it's going to be units squared. Don't forget your units. And that's going to be the area of trapezoid ABCF. The image below shows circle H with inscribed isosceles triangles ACD and EBD. Given measure of arc ABC is 130 degrees, measure of angle BDC is 25 degrees, and measure of angle DFB is 115 degrees. Use what you know about angles and circles to determine the following. Sorry, I'm making it just a little bit smaller. Alright, so what we know is that measure of arc ABC is 130 degrees. We know that angle BDC, so this angle right here, It's 25 degrees. And measure of arc angle DFB, so this arc right here, is 115 degrees. Well, just looking at this, I've got an inscribed angle right here, so I can figure out measure of arc BC because it's 25 times 2, which is 50 degrees, which means I can figure out the measure of arc AB, this part, because if this is all 130 but this is 50, this is 130 degrees minus 50 degrees, which is going to be 80 degrees. Now, looking at that, if this is 80 degrees, I've got an inscribed angle right here. So this is going to be 80 degrees divided by 2, which is 40 degrees. Just real quick, another thing that I notice is if this is 115 degrees, I can figure out this angle because 180 degrees minus 115 degrees is going to be 65 degrees, which means this angle is 65 degrees because of vertical angles, and this angle is 115 degrees. Next, I need to find the measure of arc ED, which is right here. Well, what I notice is I know this angle, or this angle, so this arc plus this arc divided by 2 is going to give me the measure of arc ED. So the measure of arc ED plus the measure of arc AB divided by 2 is going to equal 65 degrees. 65 times 2 is 130. That's going to equal the measure of arc ED, which is what I'm trying to find, plus the measure of arc AB, which is 80 degrees. 130 minus 80 is 50, so the measure of arc ED is 50 degrees. For the measure of angle AGF, which is right here, this angle, there's a couple things that we need to find first. So I know that this triangle is isosceles. I know that this angle is 40 plus 25, which is 65 degrees. And I can see that this side and this side are going to be my two congruent sides, because this is obviously much shorter than these two. So we know that if this side is congruent to this side, then this angle is going to be congruent to this angle. So this angle must also be 65 degrees. Well, if I know this angle is 65 and this angle is 65, then I can figure out this angle, because this is going to be 180 degrees minus 2 times 65 degrees, or 65 plus 65. And that's going to equal 50 degrees. Another quick note, in case I need it later, if this is 50 degrees, that means arc DC is going to be 50 times 2 degrees, which is 100 degrees. So the measure of arc DC is going to equal 100 degrees. So I now know this angle and I know this angle, so I can find this angle by doing 180 degrees minus the sum of 65 degrees plus 50 degrees. Well, 65 plus 50 is 115. And so that's going to equal 65 degrees. So the measure of angle AGF is 65 degrees. Finally, we need to find the measure of angle BJC. Well, I know that this is a vertical angle, so this arc plus this arc divided by 2 is going to give me the angle of measure BJC. So I know the measure of angle BJC is going to be the measure of arc BC plus the measure of arc AD divided by 2. Well, right now we don't know AD, but we can easily find it. We know this is 50, this is 100, this is 50. and this is 80. So measure of arc AE, well, we don't even need to find AE. We really need AD. So that's going to take away 360 minus these. So this is going to equal BC, measure of arc BC, which is 50 degrees, plus the measure of arc of AD, which is 360 degrees, minus the sum of ABC, which is 130, plus DC, which is 100. So 130 plus 100, all divided by 2. So we have 50 degrees plus 360 degrees minus 230 degrees, all divided by 2. 360 minus 230 is 130. So 50 plus 130 is 180 degrees, and divided by 2, it's 90 degrees. So this angle right here, BJC, is going to be 90 degrees, and that is our final answer.